Welcome everyone to my talk, Icinga for Windows Evolution. As far as I know, it's the last day in this room for today. So yeah, if you have questions, we can maybe even overextend, but hopefully not. So who am I? Who don't know me? My name is Christian. I'm working for NETWAYS in the... Yeah, okay. Yeah, okay. I have more hair here. So I work in the sales department at NetWays, basically. Sales guy at day, developer at night, and I'm the main developer for Icinga for Windows with people from Icinga behind to help to get everything working as much as possible. So basically, when we started with Icinga for Windows, we go back to 2018, where I had my first talk ever for Icinga Windows module. Who was in the talk? Oh, a few. Okay, great. And yeah, during the last years, we have come a very, very long way. So we had some cool ideas with the Icinga for Windows module, also with the Icinga web integration, which we later digged and moved forward to actually have various releases over the last couple of years. So basically the release cycle right now is around 3 to 4 releases per year to have smaller releases with less content, but more frequently to get everything running. We also had the Hyper-V and cluster release in 2021, where the customer who sponsored all this, we're very thankful for that because we had the opportunity to get into the development of Hyper-V and cluster plugins. And also in 2020, we released MS-SQL for local monitoring MS-SQL databases. And since yesterday, there is 1.7.0 available for Icinga for Windows with some cool new features. Now, when we talk about Icinga for Windows, there is one main part of every single installation we have, and that's the framework. The framework is basically the very heart of everything that comes together with Icinga for Windows. That means when you can manage your Icinga installation, you can have the plugin handling, you have all the background daemon stuff. Everything related is built in directly into a framework. Now, why do we use a framework? We get this question a lot. Why not only single plugins and so on? Basically, the first thing is with the installation wizard. Who uses the Icinga management console for installation of Icinga for Windows? Or who uses Icinga for Windows right of today? Oh, quite a lot. Who uses the old installation wizard? The start minus Icinga agent installation wizard? A few, okay. So basically the idea was that everything should be very easy, very straightforward, and it should be very user interactive to say, okay, Icinga is complex, where is your zone, where are your parents, what are your API connections, and so on. And the basic thing is, the old wizard was very, very complicated. You had 20 of questions, and in the end you are like, okay, something went wrong, I don't know what, so let's move on. With the Icinga management console, it's something like that. We have a UI-based wizard that guides you through very much basic stuff, like how are your endpoint names, or basically how you want to connect your agent to. Is it receiving connections? Is it connecting to the Icinga master, for example, and everything related. And then you can get a very, very cool summary in the IMC, and you can simply use this as template for your other Windows installations later on. Then we have with 1.6.0, we released the Icinga repository, which means we can now manage every single component by Icinga for Windows with an own repository. So if you, for example, in the past had to install plugins and for Hyper-V and MS-SQL, you had to specify 3 different locations from where the plugins should come from or the packages should come from. With Icinga 1.6.1, we changed this because you have now one entry point. You can extend it with additional packages, own packages, and simply use PowerShell functions or the management console to install them. So if you want MS-SQL 1.2, which are inside the repository, you can simply hit them and install them very easily and even allow automatic updates by simply running an update command. And everything will be updated, including the agent. Now, JR profiles. Who knows what JR is? Okay, if you, glad you know what is blaring. So, what is JEA? JEA stands for Just Enough Administration, and it's a tool provided by Microsoft directly to ensure that users only have enough privileges to run the commands required. So, simplified, it's a sudoers on PowerShell on Windows. So, for example, if I get access to an Icinga Windows machine and they want me to restart the Icinga service but do nothing else, they can grant me the permission that I can restart the Icinga agent service as administrative user but can do nothing else. Everything that is executed within the JEA context runs in different contexts, for example, the local system context. That's important because what it does, it makes sure that everything you need to monitor is accessible by the user you want to run the agent for. So, when you have Hyper-V, for example, you do not need to take care of what kind of permissions do you need for Hyper-V, can you access the data and so on, like snapshots, whatever. It's all there because it's done within the WinRM service right in the background based on the JEA profile. And that's very, very cool and a very, very handy feature. The problem is writing JEA profiles is very, very complicated, and what Icinga for Windows does, it will create the Icinga for Windows JEA profile based on your installed modules for yourself. So if you install the basic plugins, for example, and the Hyper-V plugins, and create a JEA profile, you will get every single command that is required to execute these plugins, but no management function is added to this. So you can't restart any service, you can't, for example, modify the PowerShell configuration, but you can run a Hyper-V check, for example, for your cluster health, and so on. In addition to that, we also ensure that we have a look on the modules, for example. If you run add type functions, if you add command script logs and so on, that could compromise probably your JEA profile, we'll print you a warning that have a look at this file to ensure that what the developer did is valid before you compile your JEA profile and use it. Now, if you're not convinced why you use a framework, let's talk about the plugins. Who knows the basic architecture for an Icinga plugin, regardless if written in C++, Bash, and so on? What are the main things that you need to take care of? Anyone else? You need an exit code, some sort of output, and need to handle some sort of thresholds where you want to alerts from, right? Sorry? Yeah, performance data, that's also a thing. But that's the basic stuff. You don't need performance data, but it's helpful. Yes, that's true. So, it's very easy to write a plugin. So at first, sure, we need to fetch the data that we need to monitor. Let's say we want a percentage of our CPU. Now, we need to compare it to some value. And then, let's say we want to have some output, and we want to have a warning. So, that we do for the critical value, and if everything is okay, we print, of course, okay, I can't write, great. Now, performance data syntax. The labels. Very simple. You simply add a pipe to the end of your command, then you have a label name, you have the current value, you have some sort of warning, critical, minimum, and maximum values added, all separated by simple semicolon, not sure what the name in English is. These all are optional. That one should be added because you need a current value at least, and of course you need a unique label name. Now, if we add this to our code, sure, we could refactor it and everything looks a little proper, but what we have, we add now our performance data here as well, and looks great. Plugin threshold syntax. Who knows what the plugin threshold syntax for Nagios and Icinga is? Who knows it? I see a few hands. Who knows these? Who uses them? Okay. So the funny thing is, These arguments are very helpful because they allow you to determine how should a threshold be compared to the basic value. Do you want to have lower or equal to something? Do you want to exclude or include some values? It's very helpful. But when we start to implement this into our basic plugins right now, then, sorry, but the presentation slide won't handle that because it's too much code. Now, if you do the same thing with Icinga for Windows with the framework, the same exact use case, it's like this. We fetch our values, and then what we simply do is we create a check object. We provide the label name, we provide our value, we say our base value, which allows us dynamically to ensure that we can fetch within our threshold values between percentage and static values. So if you're using a partition, for example, you have 0 as your minimum, and for example, let's say 250 gigabyte per maximum. If you add the base value, the 250 gigabyte, you can automatically say, I want to say 60% from my used or free space, and the framework, the check object, will automatically calculate everything based on that for you. There's nothing to worry, and of course, it's a percentage value, so we simply add the unit. Now, we have an object, and we can simply say 1 out of range and crit out of range with our thresholds that we previously had, which are 50 for warning and 90 for critical. The 1 out of range and crit out of range does exactly that what the Nagios and Icinga Plugins threshold guidelines tell us. Use the syntax and compare how does the value match. And then in the end, we simply compile our check result. And that's how it will look like for all the examples we did. We have our CPU load is okay, 30. The same with the performance data added, and Icinga for Windows adds dynamically the OK value, the unit, and the performance data without having to worry about anything. And that's the point, because you no longer have to actually consider on how is a plugin designed, what you need to do, because the framework will do most of the stuff for you behind the scenes to ensure that you can focus on adding your values and checking on how do you want to compare them to every state. And that's very, very easy because it allows us to extend the framework functionality based on feedback from our developers. If they want a new feature, if you have a new feature, we can simply extend the functionality and ensure that every single state works properly and is very, very easily doable. In addition to that, if there's a bug in the conversion or anything, you do not need to update 10 or 20 plugins. You simply update the framework, and the framework will then provide proper data. And it's more readable because it's only 4 lines of code, with previously a lot more. Now, oh, sorry. I need to check something. Yeah. I have the 10-minute version. Should I play it? So. So, with Icinga for Windows 1.7.0, we did one thing, and we focused a little more on actually getting developers integrated more easily and to make things a lot more easier. Now, for example, we have several types of Icinga for Windows components we can create. We have plugins, which is very simple. We have background daemons that can be used within the Icinga for Windows service to provide additional metrics, information, or provide a REST API. And we have API endpoints we can use, for example, to fetch virtual machines from our local Hyper-V to provide them a REST API or other inventory data. So that's quite simple. Now, when we have a look at, for example, the REST API, we can simply do invoke Icinga web request and have a look. So that's already done. I hope it works. Yeah, SSL. Because it's the agent certificate, we need to add that. And we have our REST API, and we have some endpoints available, which is the checker endpoint right now to execute checks over the REST API, which is a feature we introduced a while ago. Now, can you read it, everyone? Okay. So, now, just for demonstration, I will restart the service and query it again. And we should have the same result someday. Maybe. We have it. Okay. Now, creating an API endpoint, a new API endpoint, is documented within our developer guide. Now, to get things started, we can do new Icinga for Windows component, name OSMC, and can do component type API endpoint. Now, it will automatically create a new PowerShell module, OSMC, within the same directory the Icinga PowerShell framework is installed to. And if we now restart the Icinga for Windows service and call it again, then we will directly see, hopefully, that there's a new endpoint available which is called OSMC. There it is. Now I can simply call the endpoint, and the get API endpoint is installed, without having much knowledge about how the entire API endpoint handling works. Now, what I can do, open Icinga for Windows component editor. Let's say I want to have the OSMC plugin. I can open it directly in code. If you have any editors we should add here, because right now only Visual Studio Code is supported, please submit a simple feature request, then we can add that as well. Now, if we have a look on the module right now that's generated, we have our, I can make this a little bigger, I think. Is it fine? We have our basic module created, which means we have our root module, we have a unique ID, we have some basic author, company name, copyright descriptions. Here you can also use the new Icinga for Windows component to override many of these by default, so they're already present within the manifest file. You have already here some nested modules. We have 2 files in addition created to here. We have some functions to export and everything prepared for the Icinga for Windows repository, which means you can take this entire component, create a zip file based on that with the publish command, and then add it to your own repository for your own module. Now, for the endpoint part, we have the simple register function that is a static function from the framework directly, which is called, so everything within the namespace will be added. And also we have our starting point with some basic guides, what you can do, with a link to the developer guide on where you can get additional information on how it works, with a simple example. So, hey, everything is installed, you can move on with that. Now, if we have a look at the management console, we have the possibility within the manage environment part to actually manage background daemons. So right now, we can register the service check daemon because it's not registered, and we can unregister the REST API and the service check daemon. What? No idea why it's here. It shouldn't be, but okay. So now, what we can do is we can create a new component. And let's go that way. Change the type. And now, what we can do is if we start the management console again, and I hope this works, we have the OSMC daemon right now. Because we tell them it's a daemon, Icinga for Windows already knows it's a daemon, and you can start registering it right here. Now, the same thing which applied for the API endpoint also applies to this, because what we can do now, also open this repository. Everything is created in the same way. The structure looks a little different. We have the daemon. We have some handling here right now on how the actual daemon is started. That's our entry point for Icinga for Windows itself. And we have some thread management, and we can add our data, and we already have here everything prepared. So for example, right now, you can start writing your code inside this function. Now, let's do so. Let's, for example, add a new file to this and say, write Icinga hello. And then let's say add content, say users public OSMC. Yeah, I should start using smaller sentences. So, what we can do right now is that we simply, or what happens is that once the daemon is loaded, it will write data to this public available path. So we don't have to worry about permissions or anything else. And what we can do is we simply add this function into our daemon. Now, the thing is, when you create the PowerShell modules, as we just did, you need to update the nested modules file. Now what we can do is we publish this. It's updated, which means we have now our nested module entry already up to date. If you create plugins, for example, the publish command will automatically create the plugin documentation for every single plugin within this module, within this component. So, if we now go back to the daemon, we can register everything, and then hopefully we should get an output to this. Register, we register the daemon. Yes, I want to register it. Restart Icinga Windows service. And now, hopefully, there it is. And now the background daemon is executing the code, and we get every time the hello. And you can do everything in the background. You can automate tasks with all the privileges and so on, what you want to do. It's very, very easy, very, very straightforward. Of course, we have additional examples within the developer guide where we explain each single function, how it works. But for a developer getting started, wanting to do something, it's very easy to have a very simple entry point of executing everything. And of course, we can also release package path, say users public, create release package, and what now happens is it will publish Icinga PowerShell OSMC daemon version 1.0.0 inside the public folder, and what we can do is we use this in our repository manager to deploy it on all Windows environments. What also happens on the publisher, if you use Git, for example, everything starting with a dot is removed. So if you have .github, .vs Code, or everything else, it will remove from the folder before publishing, so only the Icinga for Windows components remain in the folder. Now, it's easy to create actual working basic components, and you can start creating your own plugins, your own daemons, your own API endpoints, and yeah, if you want to share them, you can, of course, always open a pull request. If you were in Voice Talk, you probably know how to contribute your open source code. So basically, that's it, because we want you to actually contribute if you have ideas or everything to make things a lot more accessible and more easier than it was. Now, when we talk about plugins in general, we have some basic Windows plugins available that cover the basic stuff like checking files, checking directories, memory, CPU load, and so on, including services. We have Hyper-V plugins for snapshots. We have plugins for overcommitment. So you see if your overcommitment is very much exceeding your entire host limits. We have cluster plugins available for cluster shared resources and MS SQL plugins for basic MS SQL health and some performance metrics. With 1.7.0 we changed one thing, or several things, but one important thing. The partition space plugin now allows to switch between free and used memory. So it's one plugin, we renamed it. Don't worry, if you use it, you can simply reuse the alias for it. That's still working. The only thing you need to do when you upgrade to 1.7.0, there's a new flag, check used, because the default is now that it refers to the free space instead of the used space. And we did the same for the UNC pass plugin. So for network shares, for example. There we can also now monitor free and used space of everything. Now, the HTTP plugin, we did some update because it was a customer request. You can now add the content for the website to the output in debugging mode to ensure that when you match something, you actually see what the website is doing and how you can filter it, for example, to make your plugin work. And the service plugin itself now supports the possibility to filter for the startup type. So if you have using a wildcard, for example, to include specific services, you can only include services starting automatic or manual, for example, to ensure that you have more possibilities filtering actual data. And of course, some bug fixes, because bugs are always there, especially on different Windows platforms, but yeah. Hyper-V will release a new version in December with 1.1.0. What we simply did is that you can mitigate unknown states for certain plugins now. So if you have no snapshots available, you no longer receive an unknown, but simply an OK. And also two other features that are upcoming for additional, deeper Hyper-V monitoring to ensure that everything is working, hopefully. Now, let's talk about performance. Who is fine with the Icinga for Windows performance right now? So many. Okay, who dislikes the performance of Icinga for Windows? Okay. So, I think your CPU approves. I think it's fine. So yeah, it's no secret. The performance, we have some issues, and yeah, we did some things to mitigate them. So, with previous versions, we tried to add a cache to the framework. So, how it previously worked was that every time you use -Icinga, the entire framework gets loaded with every single file. Great code. No wonder who wrote it, but it's stupid. So, what we did was we added caching. So every time you create a cache, only one single file is loaded for the entire framework, which includes all the code, which gave a huge performance boost and also increased or decreased the loading times by a lot. Now, the problem was that some users used it, some didn't, and with 1.6 we enforced it. There's no way to turn it off, to toggle it off. There is one single file that is attached to the entire framework that is loaded, and if there is or if the file is in the basic state, it will automatically create a cache, and every time you upgrade the framework, it will automatically update itself if you use the Icinga for Windows features for that, which ensures that at least for the loading times, we have a lot less time to waste and lots of CPU resources are spared. Now, in addition to that, we also added a REST API module to Icinga for Windows. That's the one I showed you before. We have an API checks feature which allows you to execute checks over the REST API within the Icinga for Windows daemon inside the PowerShell, which means that the execution time is much less because no additional libraries need to be loaded for every single check because everything is already there. If you have a look on how the performance is for these checks, if you execute a check on the local PowerShell, it will take around 8.13 seconds, depending on the load of the system, on how fast the check is executed. The problem is the longer the check takes, the more CPU resources it takes away, which makes the entire system less responsive and not usable anymore. If you use the Icinga REST API for Icinga for Windows, the execution time is below a second, which means the performance difference between these is 1,000%. That's a big number. So everything is fine, right? We have the REST API, everything is working as expected. Not entirely, because we still have one problem. Every time the Icinga agent is executing a check, it will create a new Icinga PowerShell, which means that for calling the entire REST API and to load everything that it actually works takes around 5-6 seconds. And if you reduce the 1 second we had before, that only the CPU check itself is, we have still 5 seconds remaining that are still on the PowerShell side because we can't really do anything about that. And to illustrate it, that's the problem. We have the agent is calling the PowerShell is calling the REST API, and then everything goes back to Icinga. And that's great. Now, what if the agent directly talks to the REST API and leave the local PowerShell on the system entirely alone? Because honestly, we don't need it. With the REST API, we can do it. Now, that's I don't know how to call it. It's an experimental thing we are working on right now. It's not ready for production yet, but that's something we are working on right now and can hopefully release someday. So, where is it? Is the web working? No. Connection lost. Did I lose my VPN connection? Yeah, I lost my VPN connection. Please? Please? 9! Oh, come on! Wait, what? Okay, give me a second. I can do it. Oh, come on. I should have done the same thing as Bernd and used a Docker container. So I disconnected from the VLAN now because I thought it's not working. Come on. So, okay, now we have it. Now please let me into the VPN. Thank you. Please. Thank you very much. And we have an Icinga Web 2. Great. So, now, we have a load service right now here that is... I wasn't connected to the Icinga agent. We need to wait some seconds for the Icinga agent to connect. So, I have two services here right now. For demo case, we have the Windows load check, which is executed locally over the REST API by the Icinga agent calling the PowerShell. And I have one service that is using the experimental method we have right now internally working. And I think the VPN just died again. Please. Oh, come on. Oh, come on. Work. Do something. That's interesting. So imagine right now that I showed you the check result, And the check execution for the local check is around the one we saw right now with the around 6-second delay. Imagine that. And then imagine that the API check we did was around 0.8 seconds in execution, depending also a little on how the load itself is. I try to get it to work, but I'm not sure if I can. The funny thing is the entire day the VPN and the VLAN work perfectly, but especially when you are here in front of the desk, nothing works anymore. That's great. So, let's see. We are not connected because we require the agent right now to connect, but basically that's it. The idea behind is that the agent will no longer call the PowerShell to execute the check, but that we want to implement something inside the Icinga agent that you can tell that you want to connect to the Icinga for Windows API directly and no longer depend on the local PowerShell call. So you still require PowerShell, you still require the framework and everything related, but you only require it to run it within the daemon itself. And then we hopefully get rid of the entire performance issues we have right now. Because, of course, a plugin execution will still take some resources, but the less time you take the CPU to work on something, the more time you have on something else. Now, did this make sense? I have no idea. So, we have right now 5-second execution time here. That's the invoke Icinga check is CPU. And if we go to the API, hello, and scroll down, then we are right now at 1.2 seconds. And we can see Icinga for Win API. The name is to be changed. It's just something internal right now. And if I go on check now again, then we hopefully get a result faster than I can hit refresh. And now we're 0.5 seconds because no local PowerShell is executed. Because everything is directly, the Icinga agent locally will directly talk to the Icinga for Windows API and execute the checks with all the arguments that are set within the check command. That's something we're working right now. We're not sure when it's production ready, when we can provide a beta or an RC for this, but it's one of our priorities to get this working properly. How's the time? I'm doing fine. Now, what we did is preparations. We deprecated the REST API module and the API checks module that you can right now download from the repository manager and from GitHub, and directly integrated them into the Icinga PowerShell framework. That means if you have Icinga for Windows 1.7.0, if you update to it, you can remove both modules from your system because they're right now directly built into the framework to ensure that once we are production ready for the update, everything is already prepared for the API check handling, because this is something we want to simplify and not tell you, yeah, you need to install these 5 components as well to get it working. It should be added directly into the framework, and that's what we did. So, based on all that, what we did there, what are we going to do next? There's still some overhead within the framework, especially when executing plugins, for example, that we calculate certain values multiple times because they're not entirely sure if the value was wrong, so we validate a lot there. That's something we want to redo and also ensure that the entire handling and management of Icinga for Windows is a lot easier, which means we want to integrate much more tools directly into the management console, allowing you to have a UI to configure everything. I know we are all CLI-based guys, but the issue is that the more complex the solution gets, you can't remember every single command that is available that is required for usage. And that's the reason why we added in the IMC. And in the IMC, you can still print the command that is behind each single function. So just to show you what I mean, when we switch to the IMC and go back to the background daemon registration, you can press L, and below you see the command that is executed behind the IMC. So if you're curious about that, it's all there. You can have a view, it's blue and blue, that's great. But basically that's the idea behind that. That also means that we will work on something to export the entire IMC config that allows you to configure one example host with everything included, how the plugins are installed, the locations and so on, and deploy that on every single machine. So you have to configure only one system, regardless if it's agent or Icinga for Windows specific tasks. Everything is exportable, and you can simply run one install command and configure everything from there. Plugin improvements with 1.8, we will add a new plugin that allows to monitor directly the CPU and memory usage of single processes that are running within the task manager, allowing a more deeper check if, for example, Icinga for Windows is taking too much memory, too much load, or everything related, and also extend the Hyper-V monitoring itself and ensure that all standard plugins we have right now have the same basic behavior, the same general arguments, and also to ensure that, for example, on Windows updates, you can also filter for severe updates and optional updates to give more flexibility with the monitoring itself. And that's it for my presentation. I think I'm good in time, actually. Didn't thought about it. So thank you very much. And if you have questions, we can get into them.